Give me the signal. Throw a finger.
Got it.
Hey, got it. Highest stargazers, whether you're in our club or not. I'm Ron Heron, your host, and welcome to the SBAU Astro Hour, our weekly little blog podcast of the board members for our South Coast Longtime Telescope and Astrophysics Club, the Santa Barbara Astronomical Unit. This is episode 83. It's about a year and a half on Monday mornings. We've been doing this for the week of September 26th. It's Monday morning, 11 a.m. through next Sunday, October 2nd. And we are live in our computer dens and man caves, catching up on the night sky and other space developments now that we've crossed into the fall equinox 2022. That was last Thursday. Got a lot going on to talk about. Before I introduce the rest of the board, I'm Vice President. We'll meet the President, Outreach, and Webmaster in a minute. We're going to track the outer planets this hour, starting with Mars, ending up with the gas ice giants, Neptune at the end. Catch up on some NASA missions. I count 3. They're coming right down to the wire. One of them can't get off the ground down in Florida. And the galaxy for our Milky Way, they thought it was, I guess, a nebula at one time, but it's now a galaxy like us. It's called a analog galaxy. It's out there. So let's meet the president. Hello, Mr. President, Jerry Wilson.
Hello, good morning.
Married to Pat, his wife, Pat Forgy, and I guess his doc just gave him another 13 weeks of life. Renewing, and Chuck McPartland is our outrageously outreachable outreach coordinator in front of the flag from Ukraine.
Good morning.
And here's Tom Totten joining us, former webmaster, cut loose of the planetarium job for the fall and gets to join us. And we got silly stuff. We'll kick off right now. Incidentally, we're on YouTube. You can watch on YouTube. You can see all the old shows. Been doing this since March 1st of 2021. And doggone me to get silly science cartoons sent to us by the president. I don't know which ones you want to call up, Jerry. Jerry is acting as webmaster on this, but let's look at our silly levity here. This would be as a joke. Yeah, Uncle Jay. The girl says to the man beside her, "Do you know why hummingbirds hum?" And he says, "Oh, bad filter capacitors, perhaps." And somebody said, I guess mom in the background, that's not what the, oh no, she says, that's not what the bird book says. She apparently has got a one of those, what's the guy's name? It's not going to come to me, that did all the pictures of the birds. Audubon. She's a birder. Not the most rip snorting funny cartoon, but it's kind of interesting that he's sort of like Bruce Murdoch, who said he loved this cartoon because he himself is an engineer, and it definitely touched a nerve. Uncles say he doesn't understand the jokes. Suppose it could also be a ground loop, something about the hummingbirds humming.
Yep.
Okay, let's go to another one. Oh, now this one grabbed me. Math notation. Don't know if it's supposed to be funny, but it's definitely a thought provoker, especially if you're into math. And I did some math later on. If I get a chance, I'll explain it to you and see if I'm right. Particularly the old math problem known as imaginary numbers. What exact number times itself gives you a -1? Can't be done. So we got to imagine one. If mathematics is the language of the universe, I wonder how the first extraterrestrials we might meet have tackled this problem and solved the square root of -1. Is this supposed to be Voltaire or is it Rene Descartes? Who said, I think, therefore?
Descartes.
Huh?
Descartes.
Descartes said it. So are the 3 dots in the middle supposed to be therefore?
Yeah, that's math notation for therefore.
Oh, it is?
Yeah.
Therefore. Okay. I didn't know that. All right. That's good.
I think, therefore I am.
But we don't have 2 things, do we? We have to imagine them. They don't exist to make a -1 times itself.
The square root of -1. Yeah.
Yeah. What would that number?
It's an imaginary. It's what's called an imaginary number, but it's actually quite useful and pops up in a lot of real things in physics. So it's a useful mathematical tool, even if you call it imaginary.
Well, how do they denote it? What do they put down?
It's called I. It's called I, or the square root of -1. So it's I think.
Lowercase I.
Yeah.
Yeah.
Now there is a cultural difference here between science and engineering. Science uses little I for square root of -1 and little j for current density. Engineers use little I for current density and little j for square root of -1.
Mhm.
Wow. And when they take an equal sign and make one side of it point, that's either greater than or
It
less.
points to the little side.
Yeah, I got that. Okay. Anything more from your bank there? Oh, the devil says, and this is the lake of lava that you'll be spending eternity in. And I say to him, actually, we're underground, so it would be magma. This is why you're here, you realize. You idiot. Okay. I assume that's probably where the devil and hell came from, didn't it? Seeing magma and volcanoes were up. Now, this one I don't remember. No outlet, Electric Avenue. I don't remember seeing this one.
There's two of them that I haven't sent to you because it was early this morning.
Oh, here we go. Okay, it looks like an ancient Egyptian talking to an arriving spaceman. When I hired you guys, I was kind of expecting cool lasers and spaceships. Instead, they're so it was extraterrestrials and all those huge multi-ton blocks up around the sides of the pyramids. I see. What does it say at the bottom? It's just, oh, here we go. This is the rivalry between the new and the much older. We got the new guy in space, and the old Hubble is pissed off as all get out. New kid on the block out there in space. I hate him. So we're putting a little.
Over on the left, it says he thinks he's the center of the universe.
They even got better telescopes than Webb planned. There's a bunch of them that are coming.
Yes, there's a bunch of them. Yeah, it's called NASA's, I think it's Giant Observatory Program.
Great observatories, I think.
Great Observatory. Okay. Kepler, Hubble, Webb, and then there's a couple more. They're still in the hope they get funding stage.
Can you see things in the ultraviolet? Is that the other end of the
Sure.
color scale? Yeah. We don't, are there some telescopes up there that see in ultraviolet? Sure. I know this is on the red spectrum end.
Even Hubble sees into the ultraviolet a little.
Yeah.
Really? But is there an area where it crosses in and we can't see it? Like,
no.
Well, there is in
there are sections of the spectrum that are absorbed by our atmosphere very effectively. Mostly that's in the infrared, where things drop out because the atmosphere, water absorbs a lot of stuff. Not too much in the UV. The ozone absorbs UV.
The ozone what? I didn't get that.
Absorbs ultraviolet. The fact that Earth has created an ozone layer early in its history is the reason that there is life on land here.
On the surface, yeah.
The ionizing ultraviolet would have been much too intense for plant life, for life to have existed on land without that ozone layer.
Well, it was over 20 years ago, gentlemen, that I heard the ozone layer was getting, it's over Antarctica, right? And it was being depleted.
Yeah.
Because of chlorofluorocarbons. Did we solve that problem, or is it still?
Yeah.
It's receding. The biggest place affected was Australia. And when you go to Australia, you know, we went there and they have, like we do here, they have little tours, field trips of their elementary school kids. But down there, all the kids wear uniforms and part in school. And all the uniforms include hats with big brims. And so you see these little teeny kids walking around with all these big hats.
Yeah,
it's a very cute picture, but they all have to wear them when they're outside.
Well, they don't give them Crocodile Dundee knives, do they?
I don't think they go that far.
Oh, okay.
You know, can I bring something up? I had a question about how the James Webb, what area of the sky could it see? And in my mind, you know, James Webb is out farther from the Earth than looking away from the sun. You know, I'm thinking, okay, it looks directly out from the sun.
Mm-hmm.
And then I just looked into it a little bit more and saw that it's actually kind of looking sideways away from the sun. So if you can see here, the sun is coming on from the right side and the anti-sun is the left side. And the telescope can tilt evidently this much, and it's kind of looking sideways, you know, almost perpendicular. It could look perpendicular to from the sun's direction.
Yeah.
So that's kind of interesting to me that how it's restricted, what it can see. And I'm trying to imagine how it would look at, Neptune. It took that picture that you showed, looking at Neptune in infrared, and where would Neptune have to be for it to catch it?
Well, you gotta understand that this angle that it can move over 135 degrees is also out of the picture. It's like a cone torus, because it can tip to point straight at us in this picture, or it can point straight down. So there's that. But also when it's in orbit around the sun, that angle at some time in the year, that sweeps any part of the sky you want to look at.
Huh. You just don't want to get any sunlight on
directly into it. No, because it won't damage the equipment, but it'll boil off the cryogens really quickly. And it has liquid helium on board, a limited supply of it, that lets it reach the really far infrared. And once that helium boils off, then JWST will fall back to its a secondary mission, which is only covering the near and mid IR. It won't be able to reach the far IR.
IR, what does that mean?
Infrared.
Oh. And I understand it's just a couple of degrees above absolute zero?
Yeah, the liquid helium boils at, 4.2 degrees Kelvin.
Wow. And just regular old space out there with nothing there wouldn't do it itself?
Wouldn't what do it itself?
Wouldn't cool things down? It has to be...
Well, it would if you can keep the sun from shining on it. If you have a guy in a spacesuit up there and he's not in any kind of a spacecraft, one side of him is going to be about 385 degrees and the other side is going to be about minus 385 degrees on the same guy. So that's what the suit has to do. A deep space suit like that has to equalize the temperature. Otherwise, he'd have to spin around to keep from frying and freezing at the same time.
Wow. Well, okay. You want to talk NASA? Starting with what's supposed to happen today. And are we going to be able to watch that, Chuck, Tom, Jerry?
There's live cast of it, of the DART impact, live cast.
Somebody describe it. What's arriving there? It's 7 million miles away. It's not out of the asteroid belt. It's between us and Mars, isn't it?
Yeah, and it's hitting an asteroid.
Okay.
Dimorphos here is the little one. Didymos is the big one. And they're going to crash this spacecraft into the smaller one that's orbiting the bigger one and see how they change its orbit.
Yes, now these two things occult each other from Earth. So they go around each other so you can time the occultations. And that gives you an accurate read of its orbital speed. And so once it hits, they're looking for, I forget the number, either a 7 or a 70% change in the timing of the orbit. And so that'll be easy to measure. And so that's what they're looking for, is to calibrate. Because it occults, that allows us to calibrate the orbit time. And we're looking to change that observation point.
And there's also a campaign of stellar occultations that just finished up, with most of the occultations were the best observing sites were in Australia. And they're also going to continue with stellar occultations to also help refine the orbital positions coming up.
Right. Now they tested the camera on DART by taking a picture of the moon here that's just come out of occultation on Jupiter. So they're timing those things to make sure all their systems work. The software they're using, the guidance software, is a derivative of the exoatmospheric kill vehicle that we made for anti-missile defense. So, and this is an apt use of that. First, it's going to home in on the duality of the two unresolved asteroids. And then as it gets closer, it's going to pick out the real target, the smaller of the asteroids, and it's going to home in on that.
And then we can tell if its trajectory changes over time.
By watching the timing of its occultations in
stellar photometry.
Yeah.
Or asteroid photometry.
They don't call that They don't call that smaller one a moonlet,
Yeah.
is it? Okay. The only
If they don't call the big one a planet, I don't know that they can call the little one a moon. You know, if it's a dwarf planet, then maybe it's a dwarf moon.
No, they're calling them moons.
Okay.
well, if they were both about the same size, they'd be spinning around each other like binary stars, wouldn't they?
Then it's binary asteroid. Yeah.
Yeah.
Asteroids.
Now these are the sites on the Earth where called the Worldwide Observing Campaign for DART. And you can see that there's things in Australia. There's one LCOGT, which is the old name for LCO, and one in New Zealand, Antarctica.
Yeah.
And then there's a number of other ones around up in Israel and Italy, South Africa, Goldstone Tracking Station in California, Arizona. So it's covered.
And also by the space missions there on the left.
Yes. So they're all going to be looking at this when it happens. Now, if you want to see it in your backyard, ruts a ruck there.
Yeah.
Oh, it's got to be tracked because it's moving, right?
Well, it's also very dim.
Yeah.
Well, tell me this, unless I missed it and you did explain this, that probe that's crashing at what, 15,000 miles an hour is in two parts. It's going to jettison the part that
it already did. I think it's already, of course, obviously already jettisoned the little Italian mini spacecraft that's going to film it.
Mm-hmm.
Jerry, I have an image of that. If you stop sharing, I'll show that.
Image of what?
Of the DART graphic here, which shows the Lycia, how do you say that? Lycia cube?
Your guess is as good as mine.
And then DART, impact, Dimorphos is a small thing, and Didymos is a big guy.
Now you'll notice,
old orbit. Oh, it's going this way. It's going towards the
yeah,
spacecraft.
it's going to be a head-on collision.
Yeah.
Oh boy. And so that's why the orbit gets kind of shortened over here, huh?
Mm-hmm.
Yeah, you hope to slow it down.
Yeah.
With the impact.
Well, then maybe it'll impact the big one eventually.
No. Well,
It shouldn't. If it does, you're going to have to refigure out their physics a little bit.
yeah.
Wow.
But
they're likening this impact to a golf cart ramming into a semi.
Yeah.
Well, the semi may be redirected off the road at that
So
point.
I believe it's going to happen at I think it's 3:15 or 4:15 this afternoon.
Yeah,
Around
it says
4:14,
4:14 Pacific
4:14.
Daylight Time.
Yeah.
Now,
So
are these-
they're going to have NASA's website is going to have a live display with the last 3 hours around that period. Now, this time at 4:14 is not when it will hit the moon of that asteroid. It's when we will see it hit.
Yeah.
So because it takes time for light to get to us.
well, a radio
Probably
wave.
hitting around 4.
Yeah.
Okay, we're talking radio waves in this case to get back to Earth, right? Same
Yeah.
speed.
Not radio waves. It's pictures, actual pictures.
Well, yeah, but sent in radio.
Yeah. Oh, yeah. It's coded and set. Yeah, as a radio signal. Yes, absolutely.
Are these two rocks in their own orbit between us and Mars?
Yes.
It's not an oblong. It's just like a fourth planet almost in between
Well,
Earth and.
this one is, I think, a potential near-Earth asteroid too. So that's one of the reasons they picked it. It does come in close to the Earth's orbit.
Oh,
So that's,
so it's got an ellipse
yeah.
as an orbit. Okay, well, I'm sure we'll be seeing that all over the place on websites and newscasts. And it's called, in case you didn't know, the Double Asteroid Redirection Test. 4:14 p.m. today. Wow.
Yes. I have my afternoon free of doctor's visits, so I will be watching it.
Dimorphos and Didymos. That sounds very similar to the two little chunks that go around Mars. What are those called?
Deimos and Phobos.
Okay. We sure hit that Latin, don't we? Or Greek?
Greek. No, it's everything. Arabic, Latin, Greek.
Man, oh man. Just
I'm waiting till the well, that's a political joke. I shouldn't say that. No, I will. I'm waiting for the right wing to figure out that we're teaching Arabic numerals in school.
Now, we didn't have anything in your talking points about this, but you certainly are aware that NASA just can't seem to get that first Artemis rocket off the pad, and there's a new reason for that, isn't there? It was supposed to launch tomorrow.
Yeah, there's a leak in the breakaway umbilical cord.
Actually, there's a full-fledged hurricane coming toward.
Well, that's why they moved it back into the building to protect it. But the reason it didn't take off was because of this hydrogen leak on the fueling line. And it turned out to be a bigger deal than they thought it was at first. So.
All right, so that's Artemis 1 with the dummies on board, I guess.
With what?
Doesn't he?
Oh, yeah, there's no people on it.
Yeah,
The
but
first one that has people will be Artemis 3.
Yeah, and then ladies and gentlemen, I want to announce right now that next week at this time on this very program, the SBAU Astro Hour, we're going to have a young man, I think from UCSB. He's one of the NASA ambassadors, kind of like Chrissy Cook is up at the museum.
Mhm.
He's going to give us an update on the Lucy mission, which was launched from Florida, a year ago in October? And is about to swing past the Earth and the moon and get a gravity assist to go where? It's going out to
some Trojan asteroids around Jupiter.
Yeah.
Okay, but for a different reason than
And you can see Lucy is listed down here as one of the spacecraft that's going to be watching this collision.
Well, I got to tell you, NASA's doing a lot.
NASA's doing great guns.
They really are. Great illustration there of NASA's double asteroid, baby. So those are the three, Artemis, DART, and next week we'll get a rare behind the scenes. I'm sure the young man will provide lots of his own graphics and pictures and photos.
Do you know how long his talk will be? Do we have a read on that?
No, but I just
wondering if I should prepare talking points or just rely on him for the whole thing.
I would imagine he has them, but you might want to put the basics in next for us. Just so we'll know. Lucy, what does it stand? Is that LUCY, another acronym for something?
Yeah.
No, Ron, it isn't. It's Lucy. It's they think these Trojan asteroids are pristine, that they haven't been modified much, that they're looking back to the origins of the solar system. And so they named it Lucy after the fossil.
Oh, that's right.
From Africa that was one of the first hominids.
Yeah, right. The tiny little bones skeleton wasn't
even
complete.
The partial skulls they found.
So Lucy's a fossil, and these Trojan asteroids are fossils of the solar system.
Yeah,
I think that's how it works. Yes.
And they happen to be in Jupiter's orbit in two different Lagrange point areas, or similar.
They're in resonance. I'm not sure we'd call them a Lagrange point, but yeah.
Yeah, they are.
Are they?
Yeah.
Well, there's so many asteroids spread out all over the place.
Yeah.
That it's the resonance points are not points.
Yeah.
Do you gentlemen remember the Twilight Zone episode where a guy was sentenced to life in prison on an asteroid, and they had to send him rockets, and they were landing in the distance, and he's out there breathing air and waiting for his supplies to come in? It's one of the few plots I remember. I used to think, asteroid?
Yeah, I knew enough science then to know that this whole thing is really screwy. An asteroid with an oxygen atmosphere.
Yeah. Tom Totten, is Mr. Crawford on board this morning yet?
Yes, he is. Yeah, he's been watching on YouTube.
All right.
And that Twilight episode was 1959, called The Lonely Guy or something.
Yeah. He had a robot assistant that he assembled, and then he fell in love with her because she was the only thing out there. And then his sentence was commuted, and he had to come back, but they didn't have the capacity to bring the robot back.
Really?
Yeah.
I remember that. Okay.
Jack Warden was the star.
That's right.
Okay. He was the prisoner, or he was the delivery guy?
Prisoner.
He was the prisoner. I didn't remember that part. Amazing. I just knew the premise. Fascinating stuff. Thank you, Tim Crawford. Shall we go out and visit Mars, Jupiter, Saturn, the ice giants? Because it's time to switch pictures. And where are we on time? Not quite halfway through the hour. Mars is live. It's in the southeast, just before sunrise, several hours. It's at magnitude -0.5 in Taurus the Bull. And it's right nearby Aldebaran, Mars' upper right.
Yeah, it's still riding between the horns of the bull.
Okay.
So it's easy to find because Aldebaran is a bright yellow, bright red star, and Mars is too. So you find the two together, and that's where you are.
And they make a nice triangle with Betelgeuse too.
Yes, yes.
Was Betelgeuse in that picture?
It was just below.
No, it was out. I could go wide field on it. No, this is wide field.
Oh.
Betelgeuse is not there.
Just below.
Yeah.
Not quite showing.
Okay. Is Betelgeuse named after what I think it is?
It's not Betelgeuse, it's Betelgeuse.
So it's
you'll see all kinds of pronunciations. But
yeah,
I mean, armpit of the giant.
Betelgeuse is how kids remember it.
Yeah.
Okay.
So this is a full. Now this is when Mars is getting near opposition. Its disk is getting very big for Mars. At the best opposition, like in 2003, Mars was a full 25 seconds of an arc across. Jupiter's are usually 50 seconds across. So Mars was half as big as Jupiter. In its small telescope, you could see a lot of detail. Right now, it's about 11 arc seconds across, and but you're beginning to see some detail. And I've got a couple of maps here that show the surface of Mars. And one of them is made purposely blurry because it will be the features that you're going to look for in a small amateur telescope, like a 5 or 6 inch refractor or an 8 or 10 inch reflector. So this one, unfortunately, the colors are wrong here from the text that I wrote, because this is color coded for height. And Hellas Basin here is a dark color, but it's a bright color on Mars when you look at it visually. So this is probably not that useful, but here's a full feature. Now these have been blurred, so they look like the feature size that you would see on Mars in a telescope. This feature here, this reaches out, and then there's 2 prongs going down like that. That's something that I've seen before on small telescopes from my backyard many moons ago. And then this triangle, sort of like Africa, sticking down there is, I forgot the name.
Citrus Major.
Yeah, and that's listed right here. And this is Sinus Gomer. Well, I don't know, Xanthe or Sinus Gomer is, no, this has got to be Xanthe. So you can actually sit down and sketch these features as you see them, but you'll come up with something that's about like this. If you take a picture of Mars through your amateur telescope in your backyard, you're going to get surface detail that will be approaching these blurry images of Mars. We have maps that are, of course, much sharper than this, and I think Google even has an application called Google Mars now.
Yes.
Just like they do for Google Earth and Google Moon. So you can see a lot more features, but this is what you'll be seeing in your telescope.
Really?
That's quite an achievement for us.
That's what you'll
all spread out. You'll just see a disk like this.
Yeah, but those are under really good conditions too.
Yes, that's right.
There's no dust storm on Mars during the.
Yeah.
Sometimes, and for several oppositions, they were obscured by major dust storms. And I thought, well, maybe there's something about opposition that causes the dust storm, but there isn't. It's just bad timing. But it looks pretty good this year for being clear.
Hey, Jerry, I have some images that the James Webb Telescope took of Mars, and picked up the bad astronomer Phil Plait. He came up with it, made a little story about it. And if I share, so there's James Webb is looking at Mars on that angle that we're talking about, how James Webb doesn't look out away from the sun. It looks kind of sideways to the sun. And it saw in infrared, it saw this area, Syrtis Major, Huygens Crater, Hellas Basin. So this blue one here that is the small area, and the white square is this image over here and what it saw. So it's kind of interesting what it was seen in infrared. And this is actually, so he calls it the subsolar point. So I think that means the sun was hitting here.
Yeah,
so of course
that's the hot
heat,
point.
And then he said something about that because of carbon dioxide in a low basin, that it reflected less sunlight because the carbon dioxide absorbed it or something.
Absorbed some of the infrared, yeah.
Yeah.
So they were able to measure some of the thickness of the atmosphere based on the infrared reflectivity.
Yeah, carbon dioxide, of course, is a greenhouse gas, and what you're seeing is the greenhouse effect. It traps infrared radiation, doesn't it out? Yeah, this one on the left is a good picture because it's not only, you can forget all the fine detail in craters. You'll never see that in your scope, but you can see the Hellas Basin and Syrtis Major. And if you squint your eyes at it, that's the detail level you'll see. And it shows that discoloration for Syrtis Major really clearly.
What was this other image here? Oh, this is showing the atmosphere, what was going on, I guess. I guess James Webb got this information, I guess.
Yeah, this is the spectrum. And you can see over on the carbon dioxide, the band at 4.4 to 4.5 microns. You can see the CO2 has very little transmission there, so nothing's getting out.
What does that mean?
That means that CO2 has been verified as a greenhouse gas.
And it's on Mars, even though they have 1% of the atmosphere.
That's one of the things. If you could suddenly pump a lot of greenhouse gas into Mars, like CO2, if you boiled off all the poles, and which are mostly CO2 dry ice, that would thicken up Mars' atmosphere, and the sunlight would warm. It would global warm Mars, making it possibly more habitable for people. And if there's one thing that people know how to do, it's warm a planet.
Yeah.
I wonder if are they trying to show that there's water on Mars or carbon monoxide? I'm not sure what they're trying to show here.
That's the water band where it would be. And you can see it does take a little dip. And so there is a very trace amount of water there.
Carbon monoxide, that's not good.
That means they need to vent their heater.
Well, you wouldn't want to be breathing the carbon dioxide either. So
yeah, there's no real structure here. It's just passing through. So I don't see there's a lot of CO there.
Well, let's see. The purple is the best fit model, and the data is the white. Okay. So
yeah, they're filling in where they don't have data.
Yeah.
Well, the bright yellow on the photo of Mars taken by Webb, it's not really warm. It's probably the warmest on the planet. It's still way colder than here, right? Except for those sinkholes now that they've found on both the moon and Mars. I know on the moon, they've recorded temperatures of about 65 to 70 degrees Fahrenheit permanently, day and night, in these sinkhole areas on the moon.
Wow.
Or was that,
lava tube type thing.
Yeah, the lava tube thing. Or was that Mars we talked about?
That was the moon.
Yeah, good. So they
where does the heat coming from?
It's the average heat from sunlight shining down through the aperture into the colder interior. And so then it heats up, and then at night it cools back off again, and the heat starts coming out, but they stay around 65 or 70. When you look at here on Earth, caves always have a certain temperature, and they're very stable at it. That's why people put wine cellars in caves, and because the temperature is very constant and very reliable. Right. So even though it may be very hot outside, Carlsbad Caverns is always at some fixed temperature because it's the average heat of the day that soaks in. So if you can find caves on Mars or the moon, those are going to be fairly benign environments compared to the surface.
I wonder if you can cap off a cave like that and kind of preserve the heat, let the sun come through and not let the heat go out. Who knows?
I think they're working pretty well by themselves. You don't need to do too much, but I think they'll eventually go back in a cave and block it off and put weld in a big steel door or something with an airlock in it, and then pump for gas, pumping full of atmosphere.
So Ron, on Mars, I think the average temperature is like a minus 131 degrees Fahrenheit. I think that's the average. But
Wow.
I guess it can get up to 70 degrees in the sunlight on Mars, I think.
Yeah, barely for a short while.
And
I don't see any lawn chairs left out on Mars.
but it does have dust devils with its 1% of our atmosphere.
Yeah.
I believe the NASA Artemis program is on its way to find 13 different places to land on the southern part of the moon, on the bottom pole.
They have 13 candidate places. They're going to select among those once they get more detailed information on each of those 13 things.
And do they know there's a bunch of lava tubes there that could shelter us?
Not that I know of. They're looking mostly at the mountaintops and shade next to sunlight, periodic sunlight. So they can have solar cells on the mountaintops, and then they have possibly a water ice down in the shadow parts. So that's the reason they're looking at those spots. If they find a crushed lava tube, that would just be icing on the cake.
Well, do you suppose there's a plan someday to land a probe on Olympus Mons? That'd be awesome in Mars.
Well, if you say someday, I'm sure someone will want to do it at some time.
Well, if they can land it,
do you think there's carbon dioxide ice on the top of Olympus Mons? Do you think there's?
You don't usually see that.
I think it's kind of flat, like a mesa or a tabletop, isn't it?
It's a very, very slight slope. It's like a shield volcano.
Yeah, it's not like Mount Fuji.
Yeah.
But
if you want it for your ski resort, it's going to be all bunny slope until the very end. And then you have like a 3-mile drop off.
Exactly. It's three times higher than Everest.
Yeah.
And it's on that little planet where we'd be a third of our weight.
And Everest kills about between 5 and 20% of the climbers that go up each year.
That's
so Olympus Mons would have a much harder statistic.
We got
Let's take a helicopter.
Yeah.
Got rovers all over it. All right, you want to go to Jupiter, reaching opposition at 4 o'clock Eastern Daylight Time in Pisces. Is that today? Let's see.
It's today.
Rising as the sun sets, will set as the sun rises. Close to Earth right now.
Yeah. Okay. And this is past astrophoto of the day of Jupiter from Hubble. Extremely clear. Of course, you get clearer ones now from what's the one that's going around Jupiter?
Juno.
Juno, that's it. I keep mixing it up with, well, I guess I forgot that one too.
Galileo?
No, there's Galileo too, but no, there was one project that never got off the ground or got changed called Jupiter Icy Moon, JIMO, Jupiter Icy Moons Orbiter. That was back in the 90s when everybody was speculating and how much it was costing. It was way too expensive. They were going to drop a nuclear reactor on one of the ice moons that had an ocean under it. And they were going to let the reactor melt its way through the ice and down into the water. And with all these instruments, and then have a wire that would let out behind it so it had an antenna left on the surface. A good idea, a clever system, but it was way too expensive.
And that would have been on Titan?
No, it would have been on Europa or Callisto.
Oh,
Titan's a moon of Saturn.
That's okay. You're right. Yeah. I got to say, gentlemen, sorry, but I like this picture from Hubble better than I do the one that Webb took. Didn't have any color.
There's together, each one, this is more satisfying to the eye because it's something you can relate to, the colors, and we're used to it. But it's the information that they're after, not the beauty.
Yeah. This is much more saturated than you'd see with your eye.
Yeah. Yeah.
And the red
when you first look at Jupiter with our amateur telescopes that we set up on outreach, the disk is essentially blank. The first thing you're going to be able to see after you stare at it for a while is 2 dark bands going across, making it look like a double cheeseburger. So, but that's quite a bit. It takes a lot of training of your eye to be able to pick out detail on a visual image of Jupiter. It's in a bad situation for the eye. It's got a very dark background, and then the glare of the white, because this is daytime to your eye, and this is dead of nighttime. Your eye doesn't do well on both those at the same time.
Huh. How many Earths could you put in the red spot?
First, you have to get it there.
Yeah, two or three these days. It's gotten smaller.
Has it? And they don't know why such an anomaly with that much area on a giant planet like that would occur and just keep occurring.
Right.
Nobody's ever explained that red spot totally, have they?
There's a guy at Berkeley that studies the atmosphere of Jupiter, and he gave a talk at UCSB, probably almost 10 years ago now, saying he thought that the Great Red Spot was going to go away within the next 50 years. So keep your eye on it.
Okay.
Well, it's come and gone a number of times. I think that we have no pictures or drawings of Jupiter with it gone.
With what? I didn't understand it.
With no spot.
With no spot.
Well, a couple of the ice giants, at least one of them has a couple of storms of their own. They're white, aren't they? Uranus or Neptune?
It's Neptune had the white scooter clouds and a dark storm.
Okay. And really fast gas. I mean, in thousands of miles an hour, they're hurricane.
1,200 mile an hour wind.
Earth has an atmosphere that's clear and unclouded, but it has clouds in it too. And so you can see the clouds in the atmosphere. Uranus and Neptune, they have, to my eye, it has more of a homogeneous atmosphere. There's less contrast between different components on the surface. But Jupiter and Saturn, especially Jupiter, have very high contrast between different stripes and layers and jet streams and stuff. And I don't understand what the difference in chemistry is. I've never read a good explanation for why they don't mix and just go away. But it's probably something to do with the fact that it's like clouds on Earth. You know, they do go away at times. So we got more to learn. It's an exciting time. This is a finder chart for Jupiter. Let's see, when is this? This is 11 o'clock at night tonight. And this shows Jupiter, Neptune, and Saturn down here in Capricornus. The constellation that looks like, if you draw this line up, Bikini Bottom. But they're all at really good angles, up high enough to see at midnight now. And
Saturday night at Carpenter Estate Beach, we did all three of those for campers.
Okay.
We get time, Chuck. You can do a quick roundup of stuff coming up in October. You did post it online, but any major things happening dead ahead?
Well, we've got, a big Girl Scout event coming up on the 15th.
Oh, that's right. Chrissy told us.
Oh, down in Ojai, though, huh?
Yeah. Well, it's between Ventura and Ojai along 33 there, Camp Arnaz. So, and people need to go through the Girl Scout background check. But if they did the one that we did up at Live Oak, the check there is good for 3 years. So you're still good. If people who have done that security check are still good for this event.
Okay. And the tarot card readers and us are probably not going to share the same space. Astrology or us? I'm afraid not. There's a letter difference.
If I happen to be at an outreach event next to a tarot card table, I'd like to kibitz.
Yeah.
Okay. Go ahead.
I love this picture. This is a great shot. I know it's an artist rendering, but
actually it's a computer generated thing from the software, planetarium software I use, the Sky 6. I also have the Sky X, but it's not on this machine. This shows Titan way out here. These are the moons of Saturn. So that's a star, that doesn't count. But Hyperion, this is a star, and that's a star. But there's Mimas and Enceladus and Rhea and Tethys and Dione. So, but Titan is way out here. It's usually closer in. It's kind of reddish. But this is at 11 o'clock at night tonight, the same time as the finder chart that we saw on the previous page. And then we'll get to back to Neptune again, but this is a finder chart for the laggard here, Uranus, which is still struggling. It's down closer to Mars in Taurus. Up here next to this is a good feature to find it, is the Pleiades. And now you're not going to find it with your naked eye. You have to have a go-to scope or have some kind of a star hopping regime worked up on your atlas the day before, so you know which stars to go to and how far to move.
Just look for the animals in the sky, the zodiac.
Yeah.
Look for the little greenish dot.
Yeah, the word Uranus may be out at the time.
Yeah.
Did you say the constellation that's at the bottom there?
What's that?
Right below. Where is that?
Taurus the bull there, and then Cetus to the right.
Okay.
Yeah.
Aries above. I think it's technically in Aries.
Oh, which I'm on the cusp of.
Yeah, this is the border of Aries, that up there, and this is Aries. So it's technically in Aries. Just passing through.
Okay.
Oh, they gave Aries a big border area, didn't they?
Not much happening in there, though. I mean, the constellations up here. Doesn't look like a ram to me.
Just the horn.
Just the horn, yeah. So the rest of the body's hiding in here. Well, anyway, James Webb looked at Neptune in that direction. You can see the typical 6 spikes that we seem to get from its structure, optical structure. Really nice barred spiral galaxy down here.
And that was Triton with the diffraction spikes. That was Triton, the moon.
Oh, this is it?
Yeah.
Okay, wow.
Yeah.
Do we get 6 spikes because the shapes of the partitions on the gold mirror are six-sided? It has nothing to do with that. Right?
No, it's the 3 booms that go out to hold a secondary mirror.
Right. And the center one shows me that someone forgot to take the Batinov mask off.
Yeah.
Anyway, that's just a joke, folks.
But they don't.
Okay, and then you can see Uranus and, Neptune and its ring down here. And this is a close-up of Neptune. You can see there is infrared structure on here. These are, I assume, that the brighter spots are hotter, but you can set an IR camera to show hot as bright or cold as bright. So you need to read the legend, and I didn't have access to it, but I assume that's the way it is. You can see
those would be those storms, Ron, on Neptune.
Okay. But is this how Webb gets everything and then we just colorize some of it?
This is colorized.
Yeah.
It is? I thought it was blue.
Well, it is invisible, it's blue. In this color, it's just a black and white image, basically taken through that filter. The filter transmits colors that the human eye can't see, so there's no point in assigning an infrared color. If we showed it in the color it was, you couldn't see it. So they just arbitrarily assign a visible color to the filter they're using. And so this shows if you, about 3 weeks or 4 weeks ago, maybe 5, I had a list of which filters, the spectrum and which filters were used, and then the color that each filter was then a color that was applied to that filter's image. And so that gives us the shadings that we see. You can see the rings and the shepherd moons in a couple of the rings. I assume that's a moon too.
Yeah.
But
It's too bad there's not a color legend for the temperature.
What's that? Oh,
it's too bad that the picture doesn't have a color legend with the temperature that's being read. Or
it's a pretty complicated legend that you're talking about. You have to go back and go through the different bands and see what color is assigned to it. But yeah, it would be nice to know if hot's bright. I assume it is. It looks that way.
Yeah.
Looks like the band is in front at the top.
Up here?
The rings. Yeah.
The ring. Yeah, the rings are. That's the front part of the ring, and the lower area is hidden behind the planet.
I can't tell, but because of the curve here, I would assume that gives us a curve there too. So the pole is there, and then on the other side out the top.
And the rings are lumpy too. I mean, that was one of the things when they first found the rings on Neptune, they thought they were discontinuous.
Mhm.
Well, I believe you gentlemen told me in a past program that since we're finding so many of these giant gas planets around other stars, the exoplanets, we theorize they probably all have rings, and they've even seen one that has rings.
Well, no, rings are fairly short period too. One of the puzzles that we have with Saturn is why its rings are so young, 186 million years old. We had an episode on that, talk about that about 2 or 3 weeks ago.
Yeah.
And they have found an exoplanet that has a large system of rings.
Yeah.
But they don't usually form around little dinky rocky planets like us.
Sure. I mean, we've got asteroids that have rings.
Yeah.
You're kidding. I've never seen one.
Well, you have.
Yeah,
I showed it in a presentation once on members night.
Oh dear. You're on an asteroid. I had no idea. Well then, okay.
So what do you think? What do you think that glow is around Neptune? Is it dust around Neptune, or?
That's probably just an instrumental artifact.
Yeah, I have no idea. Maybe it's Neptune's zodiacal light.
Yeah.
No, that's also a partial joke too. Don't take that as I know anything.
Fantastic. Well, that's the big grand tour this week of everything out from us, starting with Mars. Ice giants. I guess there's a lot of ice in those suckers. What is this?
Well, that's another one of those weird anachronisms with astronomers. They call methane and ammonia ices, even if they're not solid.
Yeah.
Oh,
Like metals in stars.
yeah.
This going to the next topic. This is the great square of Pegasus, which is high in the sky in the evening. This is taken at a late evening. It's tomorrow night at 1 a.m. after midnight. And we move over from Neptune to NGC 7331, which is a galaxy that is listed as, it was a astronomy photo of the day, an APOD. And it's a very nice galaxy, little off center, but it's referred to as an analogy, an analog of our galaxy, the Milky Way. And this is that galaxy. The major, it shows a complete range of colors. It's processed very nicely. This is, it has yellow in the core, which is a bunch of older stars. You can see dark veins of matter obscuring the light behind it as star clouds. That's where stars are being born, or potentially. This is where they're actually in process of being born, in these red regions, where the stars inside have formed and they're starting to shine and illuminate the hydrogen. And then you have these hot blue stars, which are recent stars out here on the edge. So usually you get dark lanes. This has a lot of them. And then bluish on the outside, and it goes toward red, and then yellow on the core of that. And that's a common spread of colors that we see in colored galaxy photos, which are attempts to make it look.
If they're saying this is supposed to be an analog of Milky Way, where is the barred spiral?
I'm not so sure it's that close to being a carbon copy, but also you don't see this part out here going farther out. And I've taken some pictures of this at CalSTARS, and it gets pretty weak. There's one arm that sticks out here, but all this dense structure is missing. It's kind of asymmetric. So I wouldn't have claimed it's of course, I don't know what our galaxy looks like from this far away. Yeah. So I don't know.
And it may have been named as an analog before we decided we were a barred spiral. That's a relatively recent thing.
That's true.
But it's less than half the diameter of our Milky Way?
No, I think this picture is 40,000 light years across. So if you looked at the whole thing, it'd be 100,000 light years across, probably.
Yeah, I think it's on the same scale.
You dropped out there, Tom.
Oh, sorry.
Say it again.
The notes that came with this in Jerry's talking points says that this Hubble Space Telescope close-up spans some 40,000 light years. So I assume the picture we're looking at is 40,000 light years across here.
Okay, and the Milky Way is over 100,000 light years across, isn't it?
Yeah. But this one, it depends on how you define the edge of the galaxy. You know, there's some really faint stuff way out here that goes way out there. So if this picture is 40,000 light years across, you know, this could be well over 100,000 light years. And they've recently made claims that our galaxy is close to 1 million light years in size, but that's picking out the finest dust way at the edge you can find. So, Chuck, are you still there?
Disappeared.
Yeah. Uh-oh.
There's 3 of us pictured on screen. Well,
Time was up.
his cat came and got him, or the Russians bombed him because of that flag.
Yeah, the cat got on his keyboard.
Okay, well, you wanted to talk about something in the last 3 minutes.
All right, you got it, gentlemen. Thank you. We need to actually Mr. McPartland back, because I'm sure he knows this, and I know that you probably know it too. Maybe not. We'll see. Tom, I'm not sure about you.
I'm not sure about myself either.
All right. We all know, here comes Chuck. We all know how far out the moon is, how big it is. But
welcome back.
Huh?
Yeah, you guys all froze on me. It was really getting jerky, and then boom.
Yeah, that happens to me sometimes.
Well, it was a black cat that went in front of you there. One of your kitties that did the whole thing. Circumference of a circle. Can you see this?
Pi times the diameter. Okay.
Yeah, pi d.
C equals pi d. All right. That's 3.14 times whatever the diameter of a circle is. The moon is 240,000 light years, miles out. Therefore, its diameter would be, see if I can get this centered, 480,000 miles, right?
Yeah.
Of its orbit.
Huh?
Of its orbit.
Yeah, the orbit is the circle.
Well, wait, it's not 2 times, it's 3. Okay, I'm sorry.
Yeah.
Good times.
So
Clear
the radius is 240. Yeah, okay.
All right, here's what I want to find out right now without you telling me the answer. Just tell me, Jerry and Chuck, do you know how fast the moon is moving? Don't tell us yet, because I came up with a figure and I want to see how close I am. You don't know.
My guess, want to guess, Ron, for me?
Well, here's the 3 categories. Like a fast car, 80 miles an hour in that range, or like a really super fast Bonneville Flats car that goes hundreds of miles an hour, or like an SST, thousands of miles an hour. What's your guess?
That's something I never
6,000.
remember because it's so easy to figure out.
Yeah.
But you're going to divide the 480,000 miles by 28 days.
Yes.
Yeah.
480,000 gets you a circle of 100 and, see if I can get this damn thing. Here it is. Million miles, 1,507,200 miles divided by 28 days.
Yeah.
Gets you how much per day? 53,808 miles per day.
SST.
And then you divided that by 24. And here's what you get.
Yeah.
2,400. Huh.
I'm wondering if that's posted anywhere in Wikipedia or.
Oh yeah, I'm sure you can find it all over. But you don't need to find it. You figured it out.
Yeah.
I know, but how in the world did I remember the old formula for finding the circumference of a circle?
You never know what's in the back of your mind.
And for volume, it's pi r squared, isn't it?
No, that's
Pi r
area.
cubed.
Is it cubed?
No,
4/3
yeah, cubed
pi
for
r
volume. It's squared for area, cubed for volume.
Yeah.
Oh, okay. No kidding. All right. Fantastic. Well, that pretty much summed up.
One easy way to remember it is that if you go hiking in the mountains, you drove up there and then you're backpacking, the density of people from the parking lot is the square of the distance from the parking lot and the cube of the altitude. That's how it thins. 1 over r squared and 1 over r cubed.
Okay, fantastic. I love it. Let me tell you real quickly that I picked up a guy for our November talk who is going to take us deep inside the center of the Milky Way. That's his
Good.
specialty. And I guess Sagittarius A and all that stuff going on there. And they're cutting edge stuff from UCLA again. I guess we run out of time, and we did this without the other Tom or the Bruce, but they have perfectly good reasons, as did our president for having his telemed session early this morning. Let's do it again next week for number 84. Chuck and Jerry, take care of your pets, and Tom, you take care of Suzanne. They're lovely ladies, and we'll see you next week on SBAU Astro.
Goodbye to Tim Crawford as well.
All right, you got it. Thanks.